In the second part of section 4.3, we're going to look at connecting the graphs of f to f prime to f double prime. Okay, here we have a graph of y equals f of x, and we're asked where the function is increasing. And again, so this one's pretty straightforward. Where's the function going uphill? Well, it's going uphill from negative infinity up to -3. And it's also going uphill from +3 to 1, 2, 3, 4, 8. So from 3 to 8. So where is the function decreasing? Well, it's decreasing from -3 to +3, and it's decreasing from 8 to infinity. Where is the function concave up? And again, when we're given the function, we're just going to approximate the inflection point. So let's say maybe right about there and somewhere about here. Okay, so it looks like it is concave up from where x is 0 to approximately where x is 5. And therefore it'd be concave down from negative infinity up to 0 and also from 5 to infinity. Any x coordinates of relative maximums, we'll have a relative maximum at -3 and also at +8. And I have a relative min at x equals +3. So again, reading those values off the graph of f of x are fairly straightforward. Where it gets interesting is when we're looking at the graph of f prime. Okay, so we're going to add a justification here. So I want you to justify these answers. Okay, so we want to know where the function is increasing. Again, this is the graph of f prime, and a function is going to be increasing when f prime is positive. So where it's above the x-axis. So 2, 4, 6. So from negative infinity to -6, from -2 to +3, and from 7 to infinity. And that would be where f prime is greater than 0. So that would be my justification for that one. Okay, where is the function decreasing? Well, that's going to be where f prime is below the x-axis. So from -6 to -2, and also from 3 to 7. And my justification, that is where f prime is less than 0. At what x coordinates does f have a relative maximum? So remember, back from our first derivative test, that relative maximums occur where the derivative changes from positive to negative. So that's where it's going from above the x-axis to below the x-axis. So at x equals -6 and at x equals 3, and that's where f prime changes from positive to negative. Where does our function have a relative min? And that's going to be where the derivative changes from negative to positive. So at x equals -2 and at x equals 7. And again, that would be where f prime changes from negative to positive. Now, where is the graph concave up? So remember, if we're given the graph of f, like in the previous example, the slopes of the tangent lines on here are f prime. If we're given the graph of f prime, the slopes on the tangent lines of f prime are going to be f double prime. So again, concavity or concave up is when f double prime is positive or when f prime is increasing. So going from -4, so I'm going to be going from -4. Let me just erase that, sorry. So this is going from when x is -4, and it is increasing all the way up to 0. And from, from 5 to infinity, and we would say that is where f prime is increasing. Okay, where is the function concave down? Well, it'd be concave down from negative infinity to -4, union with 0 to 5, and that's where f prime is decreasing. Now, any Inflection points are going to happen where the second derivative is 0, so any slopes of tangent lines that are 0, and there's a sign change on either side. So therefore, at x equals -4, at x equals 0, and at x equals 5, because that's where f prime changes from increasing to decreasing or decreasing to increasing. And there would be your final answer. Okay, let's take a look at, we won't do this one with about f of x, but let's take a look at the next one. We have f prime. So again, in this question, we want to know where the function is increasing if we're given the graph of f. So it's going to be increasing when f prime is positive. So it looks like from -2 to 2, and from 2, 4, 6 to infinity. And that is where f prime is greater than 0. So where is the function decreasing? Well, it looks like it's decreasing from -infinity up to -6, and then from -6 up to -2, and from 2 all the way up to 6. That would be where f prime is less than 0. Okay, what x coordinates is there a relative max? Well, there's a relative max. The derivative changes from positive to negative, so it looks like at x equals 2, f prime changes from positive to negative. Okay, and what x coordinate do we have a relative min in our function? Well, that's going to be where the derivative goes from negative to positive. So that would be at -2 and at 2, 4 at x equals 6. So that's where f prime changes from negative to positive. Where is the function concave up? Well, the function is concave up when f prime is increasing, so -infinity up to -6. Also from -4 to 0, and from 4 to infinity, and that's where f prime is increasing. Where is f of x concave down? Well, that's going to be where f prime is decreasing. So from -6 to -4, union with 0 to 4. And that's where f prime is decreasing. And now what x coordinates do we have inflection points? Well, at all the hills and valleys. And we'll have a sign change on either side. So I'm going to rewrite this one in two cases. I'm going to do the two positive hills. So I'm going to say at x equals -6, and at x equals 0, we can say that f prime changes from increasing to decreasing. And then at x equals -4, and at x equals +4, f prime changes from decreasing to increasing. And that would be your answer to number 7. Okay, let's take a look at another example. It says shown at the right is the graph, or shown below, sorry, is the graph of f double prime. And we want to state where on the open intervals is the function concave up. Well, it's concave up, and again, they want us to explain our reasoning or justify. It's concave up when the second derivative is positive. So this would be going from -2 to -1, and also from 1 to 3, because that is where f double prime is greater than 0. Where is the function concave down? Well, that is going to be from -1 to 1, because that's where f double prime is less than 0. And state the x values for which f has an inflection point. Well, it looks like we have an inflection point at x equals -1, because that's where the second derivative is 0, and f double prime changes from positive to negative. at x equals 1 because f double prime changes from negative to positive. And there would be your there'd be your solutions to that question. Okay, the next example, is we're given again the graph of f prime, and they're asking us questions about the function. And again, they want us to explain our reasoning. Again, you can see you can ask the most types of questions if you're given f prime. So again, they want to know where on the open interval is the function increasing. So again, for part A, I'm just going to put my solution down here. It's going to be increasing when f prime is positive, so -3 up to 1. And some people will say, well, at -2 it's 0. Yes, technically that is true, but they will allow you to write it from -3 to 1. And you would just say that is where f prime is greater than 0. So for part B, where is the function decreasing? That would be from 1 to 3, and that's where f prime is less than 0. State the x values of any relative max or mins. Well, I only have one place where the derivative changes from positive to negative, and that's x equals 1 is a relative max because f prime changes from positive to negative. Question D, you want open intervals where the function is concave up. So that's going to be where f prime is increasing. So from -2 to 0 and from 2 to 3, that's where f prime is increasing. For E, where is the function concave down? Well, that's going to be -3 to -2, beginning with 0 to 2, because that is where f prime is decreasing. Finally, part F, state any x coordinates of inflection points. Well, where do I have 0 slopes on f prime? I have one there, there, and there, and there's a sign change on both sides, meaning the slope is negative on the left, positive on the right. Therefore, I would say at x equals 2 and -2, f prime changes from decreasing to increasing. And at x equals 0, f prime changes from increasing to decreasing. And there would be your answer to number 3. Okay, here is a multiple choice question from an AP exam. It says the graph of f prime has the derivative of f and is shown above. Which of the following statements is true about f? Again, if we take a look at this, it's saying, again, this is the graph of f prime, okay? It says that f is decreasing from -1 to 1, and no, that is not true. F prime is decreasing from -1 to 1. F is increasing from -2 to 0. Yes, that is true because my derivative is positive, so that would be the answer to this multiple choice question. Okay, taking a look at this question, again, another multiple choice. It says the second derivative of a function is given by the following equation. The graph of f double prime is shown. For what values of x does f have an inflection point? Again, this is the second derivative. Inflection points occur where the second derivative is 0 and there's a sign change. So I have 3 candidates. I have one here, here, and here. That's where the second derivative is 0. However, there's only a sign change at A and O, so my answer is going to be A. Question 79, this was from the graphing calculator portion of the 98 exam, but again, you don't need a graphing calculator for this question, and that's one of the things you must realize, that on the graphing calculator portion, you don't need a calculator for every question. It says the graphs of the derivatives of function f, g, and h are shown. Which of the functions have a relative maximum on the open interval? Well, to have a relative maximum, the derivative must change from positive to negative. And the only one that does that is this guy right here. It changes from positive to negative right there. So that is graph of f prime. So it would only be f only would be the only one that has a relative max. Now we're given the following. We've given the graphs of f, f prime, and f double prime. Which are the following? How can you tell? So again, some deductive reasoning here. So I encourage you to pause the video and see if you can come up with the answers to these on your own. Okay, if we take a look, again, sometimes we have to do some deductive reasoning, okay? And if we take a look at these three graphs, I have a hill on graph B right there, and it appears that right here I have an x-intercept on graph A. And this is a hill, so that if the derivative should be going from above the x-axis to below, and that appears to be the case. My graph is increasing, B is increasing up until it hits the horizontal tangent, and A is above the x-axis there. Then the graph is decreasing the rest of the way, and the graph of A is below the x-axis. So it looks like A is the derivative of B. Okay, so we know that A is the derivative, capital A, of B. Okay, again, that doesn't mean it's the function, we just know A is the derivative of B. Now, if we take a look at the next graph, okay, it looks like this graph is graph C. It's increasing till it hits right about here, and then it's decreasing. So here's a hill on graph C, and there's an x-intercept on B, okay? And as far as concavity goes, okay, it looks like I have an inflection point on C approximately here, which means my derivative is, I have an inflection point, which means that would be a hill on F prime, and that matches up to there. And that would be an x-intercept on F double prime. So I think we figured it out that C is my function, B is F prime, and A is F double prime. Okay, so you will get a handout that will help you with this assignment. So I'll give you that assignment in class, and you can take a look at that and give it a try.